TAPS working group. Welcome everybody. And I think we can get started. We only have an hour today. So yeah, welcome. Let's set a timer for 10 minutes. So we're gonna be setting timers for the individual time slots. And I'm Teresa Enghardt. For those who may not know me, I am co-chairing TAPS together with Aaron Falk. This is a note, well, just a quick reminder that by participating in this meeting, you agree to IETF policies. And if you are not familiar with these policies yet, or if you haven't read them in a while, I encourage you to read this slide along with the linked documents later. So for today, we will have a few chair updates first, and then we will briefly hear about TAPS implementations. And then for the rest of the session, we will have 15 minutes each for 3 topics that we are starting to talk about in TAPS: transport discovery, mappings, and touch points with the W3C Web and Networks Interest Group. Just a quick reminder, this session is being recorded, so please keep that in mind as you consider joining the queue and sharing your audio and or video. So if you do not want to have your audio and or video recorded, feel free to use the chat, and also feel free to use the chat for any comments that that you might have, but do not want to say them at the mic. Kyle Rose has agreed to take notes. Yeah, and he's here. Thank you, Kyle. So let's first get into the chair updates. We will cover accomplishments, plans, and issues. Can you believe it? Our last face-to-face meeting was IETF 106 in Singapore, and this is actually our first TAPS working group meeting at an IETF since IETF 106. We've been having a lot of interim meetings. But yeah, just a quick recap of what has happened since IETF 106. So we have published RFC 8922 on a survey of security, the interaction between security protocols and transport services. And now we are focusing on our 3 core documents, as we sometimes call them: the architecture, interface, and implementation document. On architecture, we have concluded a working group last call. And on interface, we have had a working group last call and received quite a few comments and also resolved a lot of these already. And on implementation, we have resolved a lot of issues, but have not had a working group last call yet. But we've been making good progress. So we've been holding regular interim meetings, roughly once a month, where we discuss issues and PRs among the authors and other core collaborators. We've had 15 of those interim meetings in total, and we may continue to have them monthly, possibly. But first, about our documents. So for architecture, I said we have concluded working group last call, and now we are holding this document until the other 2 are at this stage too. Because those 3 core documents are closely related, we plan to align them before submitting them jointly to the IESG. And while this is in progress, we are also planning to get some early reviews from application, real-time security directorate, as well as some transport experts. And on interface, we've already resolved some working group last call issues. We still have a few ones to resolve, if I remember correctly, but we're also planning to get early reviews on this document. And then on implementation, we still have a few more issues, and then we're hoping to have it ready for working group last call soon. So here's an approximate timeline. It's July right now. We are having a TAPS working group meeting. In August, we're having our next interim meeting, which is most likely, again, focused on resolving issues on our 3 core documents. And then we are hoping to get these documents ready to submit to the ISG by November. And after we have done that, we will have to decide our next steps as a working group. So I think recharter or conclude is basically what it says by default in the data tracker. But what might be happening is we could be adopting more work items, for example, transport discovery or more mapping documents. And we will talk about these later in the agenda today. Adopting these might bring changes to our charter. So that's the recharter bit, I suppose. And alternatively, we could choose to hibernate tabs, but perhaps keep the mailing list open, because as our core documents get published, we will hopefully also get more implementation experience, and then the list could continue being a venue for these discussions. Now, finally, we just wanted to remind the working group of two issues that we are keeping track of. First, author count. So our 3 documents currently have more than 5 authors each, which is more than most published RFCs have. And this will require additional justification before publishing these documents. We have had discussions whether to reduce this author count, and we don't have consensus to do it within the working group. We're not expecting to resolve this issue right now here today, but if people have brief comments on that and want to say something, feel free to join the queue. But the second issue is shepherding. So we will need to find shepherds for those 3 mentioned documents soon. And a lot of our regular TAPS participants are also authors on at least one of these documents. If you have suggestions or want to volunteer, please join the queue and or talk to Aaron and myself. And I think now we have a few minutes for discussion if people have thoughts, and otherwise we would just go on, I suppose.
So I think that we actually have a shepherd for the architecture doc, and so I'd have to. I think it might have been Philip. I'd have to go check the notes to see. It's been so long since we did anything with it. But if that's correct, then we only need 2 shepherds. Volunteers are accepted now. If you want to. Oh, Kyle. How do I?
Can you hear my video? Can you hear my audio, rather?
Yeah.
I mean, if you could hear my video, that would be synesthesia, which would be really cool. But anyway, I got sick of wearing my headset after 2 hours of mops. Anyway, regarding the author count, I mean, the problem with something like this is that, you know, like a lot of people have put a lot of time into these documents, right? I mean, you could potentially imagine like taking the set of authors and like dividing them into a couple of groups, you know, into 3 groups, and like putting a third of the names on one, a third of the names on the other, a third of the names on the last one. I wonder if we should just, you know, pick an editor or a representative for each one of them, and then just have a very clear, you know, contributor section at the end where we make it clear that this was a collaborative effort among a large group of people. I just don't, you know, like, I know it's sort of like a patent, right? Everybody wants their name on the, you know, on the official record. I mean, but on the other hand, right, I also don't know why, you know, why the IETF has an issue with, I mean, is it just because like when you load up the RFC, you've got like this right-hand column that's like 3 pages long, right? Is that the only reason why it's a problem?
I don't think that's the only reason why. I think I'm actually let's try to get some more discussion in. We're time constrained here. We only have an hour, and so let's just try to go through the queue quickly. I don't think we're going to resolve this now, but I think it'd be good if we get people's perspectives in, and then maybe take the discussion to the list. So I don't know how to manage the queue. Are you doing that, Teresa?
You basically just tell people that they should speak now. So I think
okay. Tommy.
Yeah. Just to follow up on Kyle's point, the documents do already have editors. So each document of the core docs does have 2 editors, and then the rest are authors. So just kind of putting that on the record that we do have that split we can use. I think, you know, we could look at examples like what Quick Working Group had, in which they had, you know, many people. contributing and writing a spec. Yeah, that's all.
The RFC editor tells me that there have been, in the last 10 years, only 3 documents with 10 authors or more, and only 2 with, and only 1 more with 7, so 4 with 7 or more authors, just as a point of information. And 2 of those are from the IETF. Colin?
And I think that explains the issue here, is that if you take a bunch of academics and say you're not getting credit for the last 5 years worth of work you've done, they will all immediately stop participating in IETF. So if you want me to stop participating in IETF, then this would be a great way to do it. But I find it really offensive that we're trying to take away credit for the work people have done on these documents.
Okay, so we're out of the time that we had for this slot. Let's take very quickly Cedric, since he hasn't spoken yet.
Bunch of authors to it, and we just insisted that they stay there. I mean, we just said that's the way it's going to be, and it actually went through with all these authors. I mean, like it felt kind of difficult to remove people's contribution that had contributed to the document. So it was for RFC, which one was it? 7933. Anyway, so.
I think we lost the beginning of your comment, Cedric. You did. I didn't hear what it was that you did.
We so when they asked us to cut the list of authors, we just stood our ground and said we wanted it that way because they all contributed, and we thought it was unfair to them to remove them. So that's
it. As I understand it, the RFC edit. This is not the RFC editor's policy. They have a general recommendation. So I think what we need is to persuade our area director, which is one of the reasons that I wanted to have a little bit of discussion in public here. And so let's not spend the next 50 minutes on this topic, and actually get to some technical discussion, and move on to our next agenda item. And Tommy's going to talk about implementation updates.
All right, so I'm requesting to share slides. If the chairs could approve that. Great. Okay, is this showing up okay? Great. All right, so I will be presenting this, but it's on behalf of several others. This is just doing a roundup of all of the different implementations, and I would also ask Max, once we get to your sections, if you want to just turn on your mic and talk through those slides that you did. And Michael Wetzel is not with us today, so I'll cover his part. So just looking through the different implementations that exist, this is kind of going in chronological order, so people who are watching TAPS can understand kind of where we are and how much has been built. So first, we have kind of the oldest of the projects, NEAT, which was started, kind of around the inception of TAPS. It was written in C, and it was built to support TCP, MPTCP, UDP, and SCTP. I think it's one of the main ones here that supports this kind of the racing and failing over between TCP and SCTP. It was done as a kind of academic research project that spurred on a lot of the work that we're doing here in TAPS. Technically, the project did end in 2018, and so it is not actively maintained. It ended before Quick, as it mentions here. And since 2018, the TAPS API surface has evolved, and we worked on the documents. And so the core bits of NEAT are not kind of fully in line with the current API, but in spirit, it is very much the same. Next, we have Neat Pi, which is a Python shim layer on top of Neat that's using the engine of Neat, but making it more like what the current TAPS API is and exposing that in Python. This was also an academic project and kind of as a snapshot of that. And this kind of highlights that, Neat had at its core a lot of the functionality that TAPS still maintains. And then next we have PyTAPS, and I guess, Max, do you want to talk about this?
Sure. Can you hear me?
Yeah.
Okay. Yeah, PyTAPS is basically an implementation we started a few years ago, and I guess most of the work was done at the hackathons, and it was more focused on like quickly trying out things. It's not like something that's supposed to be in production or something, just a quick Python async IO implementation for TAPS. It doesn't support all the features. It supports more like experimental things, like a lot of stuff involving framers, and we have multicast support thanks to Jake Holland. And yeah, it's open source, and you can find it on GitHub.
All right, thank you. And then last, here's the slide I contributed. We have Network Framework, which is Apple's low-level networking API. We do not have an open source GitHub project at this time, but you can kind of look at the API surface here. And this is offered in Swift and C as a system API for both iOS and macOS. It has kind of the main objects we have in TAPS, connections and listeners. We recently added groups about a year ago, and it supports TCP, UDP, TLS, GTLS, and as of this year, it supports Quick in the public API. So I invite people to kind of look at how that surface turned out. It's very much kind of the same as the others, but you can see how it feels to use Quick in a TAPS-like environment. And we also support custom framing. One thing I'll point out is that there are a lot of the properties in the pre-connection which we don't yet support. And the kind of ability to dynamically switch between protocols and have the protocol selection properties is something that we have internally that we've been using, but is not yet publicly exposed. These are the types of things that as the TAPS documents become final, we'd like to do a revision around. And that's all I have.
Thanks, Tommy. I'm really happy to see the implementation work continuing on here. If there are questions or discussions, I suggest that what we do is get through the presentations. If we've got time at the end of the hour, we can roll back and revisit some of the topics here. But I want to try to give everybody who prepared talk a chance to get through their presentation. So unless anybody has strong objection, let's go on to Martin, who's going to talk about TAPS transport discovery.
Thank you. Aaron, are you going to run the slides?
Why don't, if you are comfortable doing it, I think you should do it, then you can advance. It just makes it a little easier all around.
All right, let me call it up.
Guess we should have worked that out ahead of time. My
that would have
bad.
been nice.
Yeah, there's this
No
great
worries.
new feature.
You had one job, right?
Top
right,
left,
okay,
hold on.
share preloaded slides.
let's see how that goes. All right. Oh, look at that. You could do that. All right, that's much easier than I was trying to do. All right. Hi, everyone. Some of you have heard this talk before. If you go to the interims, there's not many of you, judging from the numbers, so I'll just jump right into it. So when I got excited about TAPS, I got excited about a lot of things, and I was a little bit disillusioned to learn that we were actually not doing some of the things I was excited about. So TAPS obviously is a way for applications to not have to consciously pick between the available transport protocols. But in practice, available transport protocols from what I understand of the existing implementations, is what is sitting around on the operating system. That is a sensible thing, and it solves a lot of problems, and there's some value in that, but it's not as powerful as it could be. Another way to have a transport protocol in TAPS is for app to bring its own, and this is essentially what a framer is, right? You're kind of bringing your encoding with you, and TAPS is applying it for you, but essentially you're bringing a lot of the protocol logic in your with your application. So this does exist out in the world, as Tommy just mentioned. Network Framework supports framers. Another way to go would be for there to be a trusted package installer. So you go to an app store or Yum or whatever, and go get a package that implements a new protocol, whether it be quick or whatever, and then have TAPS somehow understand that it's there. And then the most exciting way is to just download stuff off of GitHub. Protocols off of GitHub, and then just install them and have TAPS run them, which is dangerous because they could hijack your entire network stack. So I would be sad if TAPS, when we concluded, didn't do a bunch of things, or had a certain properties or lack thereof. If TAPS had to recompile every time there's a new protocol, that would be sad. If you couldn't use user space stuff, that would be sad, given that, I mean, most TLS implementations is user space, Quick is user space, et cetera, et cetera. We definitely want power users as a way to use bleeding edge code. I mean, I think, this group doesn't need to be persuaded about the need to implement new protocols and innovate, but also for the really kind of pedestrian problem of getting something like OpenSSL to work under TAPS. They're not going to support TAPS immediately, and for a while, we're going to have to write a shim layer on top of OpenSSL. And so that's going to be bleeding edge code until it's brought into that project in the future. Now, obviously, there's security vulnerabilities, and we don't want if your grandma ends up using TAPS, we don't want them to download a quick implementation and have their stuff hijacked. And also, like, I'm not super satisfied with the answer that apps need to bring their own protocols via Framer or some other mechanism. I think one of the really appealing things is that you don't have to marry some other implementation you have no control over. Nginx in particular has a couple of these problems. They can't really get quicker to the main line until they resolve the issue that OpenSSL doesn't support Quick. And like, they had to do their own Quick implementation because they don't really have a straightforward way to just connect to one Quick implementation they know is going to be there, or even better, have a common API where they could pick any Quick implementation. So not having to increase the footprint of their applications like that is, to me, an important outcome. So one way that this could work is you would have a protocol installer that installs both a library that matches certain standard API function names, and then it just takes its capabilities and uploads them to a directory or something somewhere that lets TAPS know that it's there and what it can do and how to access that library. And the idea here is that the application would do a pre-connection request. Actually, you know what? I'm not going to skip this slide because there are a bunch of ways to do it. We might not do it that way. So I've actually already started to write some code. I just have done the screenshot just to prove that it exists. This is a YAML file that explains the properties of the Linux TCP and UDP implementations. I'm kind of working my way through the life cycle of a connection, having written this stuff to parse this file. There's a ton of work to do. I hope to open source it. Actually, this project is useless if it isn't open source for various reasons, even inside F5. But I'm currently in lawyer hell. I hope to be out of it by the end of the year. And when it is out of lawyer hell, I very much hope that people will join me in contributing to this. This is a framework to start working to not only instantiate the TAPS interface that we've spec'd out, but also to start exercising some of these ideas about how to do this kind of discovery stuff securely. And right now, the only thing I have is not secure. It's just taking these YAML files and uploading them and assuming that they're correct. So there's a lot of work to do yet, but I'm making progress slowly now. I hope to get faster if I can get some bodies on it, not both internally and externally. Oops. And you know, Teresa did allude to maybe rechartering. It's not clear to me this is actually needs a recharter, or would need a new milestone. That's for Zahid to decide, I presume. But you know, that's kind of where this is. And I think I mentioned this in the interim. I think there was pretty positive reaction. And you know, I'm certainly interested in any input people may have. The draft is pretty skeletal on how to solve a lot of the problems that I've raised here. And that's it. Colin.
Hi. I mean, I think this is an interesting idea. It is the idea that it becomes a sort of standard internal API for TAPS, or is the idea that it's a set of things to think about, and then it ends up being very Linux specific or Python specific or whatever it is?
Well, I mean, I would hope that if somebody is implementing a protocol, that they would not want to write just completely bespoke installers. So I would hope that these ideas would make it into the other TAPS implementations. It would certainly be nice. I also, I mean, I'm hoping that this implementation that I'm working on, if it picks up, then maybe it could, like, I'm doing it so that it could potentially one day become a production thing that people have. Like, I think that would be, I mean, it's a very ambitious, but it would be outstanding success if this was a thing that was that this TAPS daemon like very commonly existed on Linux boxes.
Yeah. Okay.
Thank you. Dan?
Your manager.
Or are you just waiting for it to present? Dan, are you waiting to present, or do you have a question?
No. I had a question, actually.
Okay.
So, you know, Martin, there's a big emphasis these days on supply chain security and you know, making sure that whatever is running is actually, you know, inventoried. And this adds an interesting wrinkle into that. And maybe with that in mind, you know, future ideas related to this would take into account, you know, how this can be added to the inventory of, because you're adding a significant you know, risk factor into, you know, let's assume that one of these protocol libraries actually has a known vulnerability. How do I know that needs to be fixed? All these dynamics and you know, the software bill of materials related to that specific package and so on. Just a thought. Thank you.
Yeah, that's an interesting thing. I mean, I did call out in the draft a bunch of security challenges. I don't think I did that specific one. In the draft is a link to the GitHub. I hope, if you could file an issue there, that would be great. If not, I could try to remember to do that. But thank you, Jonathan.
Yeah. So this also implies that you're doing a a concrete implementation in some language of the abstract TAPS API. Is that something you would also think you would want to standard? Like, somebody you're writing this in some programming language, right?
Yeah, I'm writing it in C for various reasons.
So that implies that you're, you know, that yes, that you have to have a binding from the abstract API that were defined in the current documents to C, and that would need to be written down precisely how you're doing that and what data types you use everywhere and yada, yada, yada. So is that something that would be just part of your project, or something that would actually want to do in a working group?
Well, so I mean, in terms of the binding, so I mean, like, as a practical matter, there will be, like, in my slide, in the YAML code I showed you, there was like for .so file. That .so file does not exist, but that would essentially be a shim from the TAPS API to the socket interface in this particular case.
Yeah, but I mean, but things like, you know, okay, when the TAPS API says, you know, in a length field, we're using a uint64 there, or a size t, or whatever, that you know, needs to be written down somewhere. So
Yeah, all right. So I mean, like documentation is like I would love to be at the point where documentation was important. My understanding is that TAPS is not going to get to the point of the working group is never going to get to the point of like integer links for things. Now, like the particular bit for transport discovery, I think the standardizations, the two standardization issues. Number one, these libraries need to have common function names, and number two, the YAML file has a certain structure to it. But YAML is a little looser than binary or whatever. Like, but that's pretty straightforward in my view.
But I mean, I think if the goal here is that I can write code to your library and somebody else writes something else I can plug into the YAML file and the code works. Without me having to rewrite everything because they made different decisions on all these points is would be necessary for this to be actually useful.
That would be good. Yes, clearly it needs a user's guide both for a application developer and a protocol developer on how you integrate into this structure. And we have to design the structure first, and it's not even close to fully designed. This is a very, very preliminary thing, and I'm just trying to see if I have some fellow travelers that want to figure out how they should work.
Okay, so we have Tommy next, and we are a little bit behind on time, unfortunately, so I would like to move on after Tommy.
All right, I'll try to be quick. So, Martin, you had a slide earlier on kind of like the sad outcomes of what could go on there, and one of those is recompiling every time there's a new protocol. I guess if the TAPS implementation is part of the OS, people wouldn't necessarily need to recompile in order to get new functionality. But then, like, if it is a case, this is a library where I've packaged it in because I grabbed TAPS off of GitHub, put it in my app. I don't know. It just doesn't seem like it would be a crazy thing to recompile. So I guess I'd like to a little bit challenge, like, is this a particularly bad outcome? Because recompiling is still a lot easier than writing brand new code to a new interface. Like, it still gives me the flexibility of all I have to do is download the latest version, hit build again, and then it works.
Well, so like I guess what I'm saying is if I have a TAPS daemon and a library running on my Linux server, for instance, and then I install a new quick implementation that conforms to this, and the installer forces me to take the TAPS source code and rebuild it, that seems, I mean, I guess you could survive without that, but it seems bad, and I think you can avoid it. And I didn't want to, I skipped that slide about kind of the nuts and bolts of it because I don't think we have the time to talk about it. But yeah, I mean, I still think that would be a sad outcome, but your mileage may vary.
Yeah. Cool. And just kind of one other comment I would have is, I think some of this work could be done in a way that's not core to a TAPS implementation. Like, if you want to extend something, you could build it into a system kind of like how you have a VPN in which you kind of run the new protocols out in some other process in some isolated space, and the user is aware of it that way. So I guess that kind of influences whether or not we think this would be something that we would kind of need to work on here as like a core thing, or if it's just something that implementations decide to extend or not. Anyway.
Yeah, thanks. Tommy, you probably know 10 times more about operating systems than I do, at least real operating systems that aren't that are out in the world. So by all means, I would welcome comments and issues on the draft. Thank you.
Thanks, Martin. And now, shall we move on to the next presentation? Tommy with mapping. Yeah, here we go. But I cannot hear you.
I had not yet turned on my audio.
Oh, yeah. No.
All right. So I'm going to give a quick talk about protocol mappings and what we can do in TAPS to potentially work on those as our item after our core docs. Okay, so just to kind of look at where we have come from, and so we can see if it makes sense to see where we're going. Here's a history of all of the documents that TAPS has been working on so far. So, back in 2017, TAPS' first RFC got published as essentially the survey of the different IETF transport services that existed. Shortly after that, in 2018, we had kind of these documents that went over all of the different transport features for both reliable and unreliable transport protocols that were defined. Later, we came back around 2020 and realized we needed to do work to also include security in this kind of survey of all of the different features and protocols out there. And then collectively, that work created the basis for the minimal set of transport features and services that are offered. And that minimal set informed kind of what we had to have within the TAPS interface. And so that's how we kind of built these current core documents that we're working on, which hopefully we're going to ship off to the ISG in 2021. And looking forward, we see this trend in which we were kind of distilling things down by looking at all of the available protocols out there. And that kind of informed the API we've created. In a way, the mappings effort would kind of be the reflection of it, of saying, all right, now that we've built this interface and we've defined how the minimal set maps, how do we start mapping in other protocols? Because there were protocols that we didn't cover in these original documents because they hadn't been finalized yet, like Quick. And there are also things that people use as transports, like certain ways of using HTTP that aren't officially transports, and we didn't cover them in the surveys here, but it may make sense to use this TAPS interface for. So this is kind of how we could see that progression. And in a lot of ways, this effort would reflect some of the earlier efforts that we had in TAPS. So stepping back a bit, what is a mapping? What would be in a mapping document like this? So, at least in my interpretation, a mapping is something that would define how a given transport protocol interprets the various API calls that the TAPS interface defines. And it also, besides the kind of the active calls like initiate and close and send and receive, you have to define if there are any special interactions with particular properties. Multipath TCP interacts very specifically with multipath properties. Looking at how quick migration interacts with those is one of the things that a mapping document would have to do. And there's also room to talk about protocol-specific properties, things that don't quite fit into the clean TAPS overall architecture. Sometimes you may have a knob on a given protocol that you want to adjust specifically that wouldn't apply to all other transport protocols. So here's a look at the Appendix A of the current implementation document that we have in our core TAPS docs. And it kind of defines, here's a template that you can use for defining a mapping. And I think this probably needs to be expanded to include some of the properties that we'd want to cover. But it essentially says, for any given protocol, you could fill out what do you do with what's your object, what do you do with any of these given calls, like initiate with send for fast to open, what does it mean for you to be ready, et cetera, et cetera. And the implementation document currently has mappings for a lot of the basic protocols like TCP and UDP. Yep, so we already have TCP, MPTCP, UDP and UDP Lite. We have some text around UDP multicast receive and SCTP. So those ones are done. Those are also the ones that were covered in the earlier MinSet and before RFCs. Looking at the different ways that we could go forward, we already do on our GitHub have 10 open issues that we've tagged provisionally as, these are mappings. These sound like things that we could do in future mappings documents. So an obvious one is quick, but we also have issues around, how do we handle HTTP3 and HTTP2 streams? And these are things that could race against each other and are in a lot of ways useful as like a transport stream. We have an issue around how would you handle HTTP1 pipelining. We have an issue around what does a WebRTC transport look like. And then we also have one talking about TLS as a transport. In general, that would, TLS would have the same mapping as TCP, DTLS would have the same mapping as UDP. But there are some extra features that might be worth calling out, or certain considerations for exactly how the mapping works. Like when you do a close, does something map to a close notify, or does it end up sending a fin or a reset on the underlying stream? So enumerating these things would be very useful for having kind of consistent behavior across implementations. And one of the things that I thought of here that we don't have an issue for, but I think would be an interesting one, is the work that's going on in web transport. That's trying to create a web layer API on top of HTTP that's going to replace WebSockets, but it really is something that would fit very, very well into the TAPS ecosystem, and it would make sense to have a mapping document for that as well. So as just kind of one case study, we can look at Quick. There is an old 2018 document that I had worked on to define kind of the API for Quick using TAPS. It wasn't a formal mapping. Quick has changed a lot, TAPS has changed a lot, so it's quite out of date, but it gives a hint of kind of what we could do there. And since then, as I mentioned before, Network Framework, as of this year, supports Quick, and so we had to do the work to map Quick into the TAPS-like APIs, and did the work to map it as a quick stream equals a TAPS connection. And that seemed to be the cleanest mapping there. So in this example, you could go through all of the different actions that you would need to map, and you say, okay, when I initiate a quick stream, I have to allocate a stream ID. Maybe I need to start the quick handshake if that's not already done on my multiplexing group. We can define what it means to clone, how you send, how you receive, fairly straightforward. And there are certain things that we've done recently in TAPS, like adding the close group explicitly to handle things like saying, I need to do a full connection close, not just closing or resetting one stream. So going through these efforts of making sure we've kind of filled out every item, I think is actually very useful for making sure that we have all of the correct items within the main TAPS interface itself. So I think it would even behoove us to start working on some of the mappings in early draft form before we ship the core documents as RFCs. So essentially, as questions to the working group here, do we think that we should add these mappings to our charter as the item that we do subsequently after we've finished the core docs? I think one interesting one is, what mappings should we be working on in TAPS versus working on in other groups? For the long existing protocols, it makes sense to do them in TAPS. I don't expect that the Quick working group will want to have a document that here's my TAPS mapping. But when we talk about interactions with web transport and such, that's kind of a lot of inter-working group communication there. And then I think there's a question overall of, do we want to put these mapping items into a registry, or are these just documents that are references for implementation that are more informational? And I think that's all I have.
Thank you, Tommy. So do we have questions, thoughts? And we're just exploring here, right?
I guess I have one. Oh, sorry, Colin. I should have gotten in line. My comment is very quick. So, my initial reaction is, if we're going to do a mappings an effort, that we take more than one. Like, you know, I would like to come up with like a framework that leaves breadcrumbs so that we don't need a working group to do another mapping in the future. And I think if we focus on, you know, just doing it for quick, that's you know, I'd rather pick two. I don't care much what the other one is, but you get my point.
Makes sense to do more than one. Yeah, certainly.
Okay, Colin.
Yeah, so I definitely agree with Aaron's comments. I think that makes a lot of sense. I think we should maybe think about how much variety of protocols we're going to look at. Because, you know, if you look at QUIC and SCTP and MPTCP and TCP and so on, they're all broadly similar if you squint a bit. Something, you know, I don't know a whole lot about web transport, but certainly if you look at something like RTP with the very different set of control protocols that go along with it, you know, I can't imagine implementing RTCP easily within the current framework. So we should think about how much flexibility we're willing to support in the mappings, because that will affect whether we think the current set of documents are complete enough.
Thanks. Lucas?
Hello, Lucas here. I don't have much to add. I don't know lots about TAPS, I'm afraid, sorry. But putting a mapping into the QUIC working group doesn't necessarily feel like the right thing to me. Yeah, I'd be happy to revisit that question and find out more and be part of a discussion. But yeah, I think if there's a TAPS group to do that mapping, it would seem a more natural fit.
Thank you.
I'll just point out, for all the mappings that we did, we had experts in the protocols participating in the working group. We had SCTP guys doing SCTP, and we had the UDP Lite guys doing the UDP Lite, and we had lots of TCP expertise. So I think if we do QUIC, we got to make sure that there's QUIC experts who are involved in it. And any other protocol, it's not, you know, you want to make sure you don't lose any nuance in the process. Although I think we do have a lot of QUIC expertise in the room.
Sorry, just to respond to your point, Aaron, sorry, like the QUIC charter does say that we would hope that anyone developing application level mappings for QUIC would consult us. So I would turn that around to say we should probably have the expectation that we would help out with efforts that we decide on a good venue for the QUIC working group. And I'd be happy to help facilitate that wherever this work ends up happening.
Thanks. All right, we are out of time for this discussion, unless anyone has last thoughts on it. Otherwise, we have Dan. If you could share the preloaded slides.
Yep, I'm. I hope you can see them now.
Yes.
Yeah. So thank you so much for asking me to give this overview to this to the TAPS group on what's happening on the Web and Networks Interest Group in W3C. I think there are some intersection points, and I don't really know exactly what they are. And for one reason is because and I'll move to the next slide. Basically, the Web and Networks is an interest group which does not make standards, and it's really an exploratory group in terms of looking at solutions for web applications, how web applications can talk with the network to improve the user experience, basically. And the key focus topics initially were on, providing application hints to the network and from the network, as well as we started to look into some other evaluation of web metrics and how to expose certain network services up to the web layer. So in a way, you can think of it more like a top-down approach, which I think it will be interesting to see how it actually gets fulfilled with some of the work that is being done with the interface and the architecture in TAPS. So the main areas, we just got rechartered a couple of months ago, and the main focus area can be put in like two main buckets and two kind of newly developing directions. So on the network quality monitoring and prediction, it's really the ability to kind of monitor and prepare for the changes in network conditions. And we had and I'll go in more details on each specific area. But on the edge computing, there was a lot of talk about how can edge computing can be brought to the web applications, or how can web applications benefit the edge computing, pushing resources, compute, memory, storage to the edge, and how can they split their workloads. And we had I'll go again in a little bit more detail on that. There were some discussions about peer-to-peer network topologies and content distribution related specifically to web applications. And last but not least, there was a need that was expressed that there are not that many tools that emulate network conditions, and especially standard trace formats. So we started to explore that as well. So I do have a little bit more detail on the edge computing and the network prediction. The other two, as I said, we're just kind of starting to shape up some more details on that. So for edge computing for the web, we have more questions than answers as of now, and understanding exactly in what context they can be used. How can the application determine when and why should offload some tasks from the browser to another stack on the edge, understanding if a split browser architecture kind of makes sense or not. And so we had quite a few ideas that were presented, and if you have time and interest, I put the link to the wiki there that has a lot of the presentations and ideas that were shared. But basically, people came up with ideas about offloading using service workers, WebAssembly, or web workers for different use cases, for Web of Things and for web applications in general. But there are quite a few challenges associated with this. Trust is obviously one of them. You're running into a sandbox environment, and the APIs need to be very restrictive. The other thing is about how do you do the matching of what is needed with what is available, if assuming you have some edge nodes around and so on. So in any case, that's one area we're exploring. The other aspect is about the network quality monitoring and prediction. And we looked at some of the use cases where prediction is important to adapt the application to various network conditions. And we had folks from Intel presenting some of their prediction research, and really it comes down to being a bit more proactive in regards to application changing its user experience in light of the changes in the network conditions. And there are very limited network APIs that offer that type. We had somebody from Google presenting how they're using the network information API in Chrome to evaluate the network conditions. So again, with this particular one, we have a pretty extensive wiki with links to the presentations, and also keep issues in a GitHub repository if you think that that's interesting. And basically, how I see things in relationship with TAPS is that we should start looking at the use cases. I mean, in a very generic way, but I think it will be useful to start doing some mappings with what TAPS has done, some of the use cases that have been shared in the Web and Networks Interest Group, and see how they fit, and potentially either raise some other use cases, or you know, if there are any specific things that we haven't addressed, then kind of come back to the TAPS group with either more clarifications or questions, or potentially extensions. I don't know, and basically explore some of these mappings. And I think it goes with what Tommy was showing, and maybe, you know, web transport is a good example, because web applications don't go deep into the transport layer. And for good reasons, I guess. So we'll see how at least a web API can translate in a more restrictive way, I guess, to what is currently defined in the TAPS API architecture. And so identify the gaps and rinse and reuse, and, you know, circle back as needed. So that kind of concludes my overview. I hope it was informative. I didn't have anything specific. I just wanted to share what we were doing, and provide you with references to materials that are relevant, and hopefully we'll do our work on our part to see how the current architecture can map to some of these requirements that we talked about, or at least we identify. That's it. Thank you very much. So I hope I got some, I played some catch up. Thank you.
Great.
So,
Aaron.
yeah, thanks. Trying to use the tools that we have here. So this was interesting, Dan. I was really not familiar with the work, and my take on it is that it represents maybe not a new kind of network usage, but maybe a new pattern in application development that might affect you know, what transports are useful. And I think that from the point of view of TAPS, it would be helpful. So I think it's really the best thing that can come out of this is that the folks who are doing your work are aware of the existence of TAPS and can look at it and see if it's useful for you. If it's not useful because we haven't picked the right abstractions to expose that allow you to choose or take advantage of the transport protocols that are available, that would be really useful information for us. It means that, you know, we've got some work that we need to do. So I think if maybe I'm just going to throw this out there, maybe it would be worth having somebody from our group come and give a talk to your group just to introduce the TAPS architecture.
That was kind of what I was going to suggest too. One of the sessions in one of our meetings, just to have an overview of the architecture, the interface, and you're right. The web API has its own unique restrictions that need to be taken into account, and at some point somebody may ask, why do they need to have visibility into all the way into the transport layer? But we just need to peel the onion a little bit more. And I think that's what the objective was for today.
Great. Well, thank you so much for coming and telling us about your work.
Thank you.
Okay, do we have more questions, thoughts? Well, if not, I guess we are actually ending 30 seconds earlier.
Good chairing, Lisa. Ended on time. I think before I had you as a co-chair, I have never ended a meeting on time. So well done.
Well, thank you to all speakers for actually keeping well within the time.
Yeah. Reminder, we have an interim coming up. If you're not on vacation and you are around on August 20th at 1500 UTC, you can tune in for the next installment, and we would love to see you there.
And if you're not on the TAPS mailing list, I invite you to subscribe. I will be sending a reminder for that interim meeting as well.
For the session.
Okay. Bye, everybody.
Shahid, you have
Bye.
any last words?
No, I just want to thank everybody for this session. It has been really good, good turnout. And I think, as I said in the chat, we might actually consider doing this more. Thank you.
Great. Thanks.
Bye.
Bye.